Up next, we have Mr. Chris Tapp, Chairman of MISRA C++ Working Group, Technical Specialist at LDRA UK, who will be presenting on "Do all your build tools need to be qualified?"
Hello and welcome to the industrial track of ESSS 2021. My name is Chris Tapp. I'm a technical specialist with LDRA and I'm also chair of the MISRA C++ Working Group. I'd like to talk to you today about tool qualification, so get an understanding of what tool qualification is, why it is needed, how tools are qualified, and also look at a little bit into the tools that need to be qualified as part of the qualification process. So the first thing to understand is, what is tool qualification? Well, basically it is a process that's used to ensure that a tool is capable of doing the job that it claims to be able to do. In other words, it has to be at least as good as the manual processes that it will eliminate, reduce, or automate. The essence of tool qualification is really a process by which a user proves that the tools they are using are capable of properly performing its tasks. The idea is that you do this once, which means you then do not need to verify the tool's performance whenever it's used within the project. So you do it once at the start of a project, and then you can assume that it is behaving as expected for the duration of the project. More simply, it's a process used to establish confidence in the use of the software tool by making sure that they work correctly or as they are expected to work. So why do we need tool qualification? Well, really, it's needed for any project where software failure could have some serious consequences. That may be risk to life, financial consequences, or even just the reputation of a company. If you're producing a product that's widely circulated and you want to make sure that your name is seen in a good light. Some examples of this are sort of within power generation, power distribution, machine control systems, sort of building infrastructure, so possibly something at the top of a building, a large mast that's used to maintain building stability in earthquakes, or some other project that has a high safety requirement associated with it. It might also be necessary for systems, for development of systems that are not directly related to a product. So, for example, you may have a system that's used to program a medical device within a manufacturing facility. That also needs to be developed to an appropriate safety integrity level, with it being at least as high as that of the product itself. For example, you don't want to end up with a device having the wrong firmware in it, or having inappropriate calibration data loaded in it during manufacturing. So how are tools qualified? Well, as with most other things within sort of high integrity software development, it is related to a process. And the process typically involves three phases. You form a tool evaluation phase, and that is used to decide which of the tools within your project need to be qualified. Then moves on to a phase where the tools themselves are actually qualified, and that's where the performance is measured and confirmed to be as needed. And there is also a review of the qualification artifacts that are produced during the process, where these are assessed to make sure that the tools are actually behaving as expected and that they are not going to compromise the project in any way. So the process starts off with this sort of tool evaluation phase, and the intent of this is to just get an understanding of the tools and how they work within the development environment, and to see if there are any concerns that may be raised by their use. So we start off by understanding what the intended purpose is. Why is the tool being used within the project? What's its purpose? We also look at the inputs and outputs of the tool. So, for example, it may be taking source code and producing reports, or it may be producing data files. So we need to understand what the workflow is associated with the tool. And we also need to look at the environmental and functional constraints. In other words, where is the tool being used? How is it being used? And are there any restrictions that must be observed when the tool is being used for it to behave as expected. The aim of this is really to evaluate the tools to decide if there is any possibility of them introducing errors into the software, or for them failing to detect errors that may be in the software that they are reasonably expected to detect and point out to the developers. Basically, qualification is going to be required if there is a chance of any tool detecting failing to detect an error or introducing errors into the software itself. And that's generally going to be true for tools that are involved in code development, any tools used for generation of code, so automatic code generation or compilers, and also any verification tools that are used to ensure that the product is meeting its functional and non-functional requirements. So looking at the tool evaluation itself, there is a set of information that has to be collected to allow a tool to be evaluated, and that will include a use plan. So in other words, how is the tool going to be used in the project? Do we understand how it's going to be configured? Do we understand the use cases that the tool will be applied to? And do all the developers understand how to use and run the tool on the data files that need to be checked or processed? We also need to build up a list of the features, functions, and properties that are going to be used. So in other words, we may have a tool that has a lot more functionality than is needed within the project. So what we need to do is understand which bits we are going to use and which bits we aren't going to use, because there's no point in qualifying aspects of a tool if they aren't going to be used within the project itself. It also helps if you can obtain a list of any known defects and workarounds that may exist within the tool. It's quite common for development tools to have some known issues, and the vendors will often publish a set of guidelines that say if you follow these guidelines, you will not run into these problems. It's also obviously then important to document the expected behavior of the tool, make sure that everybody knows what the inputs are and what the expected outputs are. And it's also useful to have an understanding of how a tool is going to behave in the presence of errors. So, for example, what does your compiler do if it can't find a source file or whatever? In most cases, it's fairly obvious, but there are some errors that compilers may be able to detect, but which they don't have to report on. So it's useful to know if there are any of these restrictions in there. The evaluation process itself is used to determine if the tool is then able to introduce errors. If it is, we can then start to build in some mitigations to make sure that that doesn't happen. And we can also look at identifying mechanisms within the tools that could lead to them failing to detect errors. So in terms of the actual qualification, there are several methods that are used to qualify tools, ranging from sort of fairly ad hoc informal methods such as increased use, confidence from the use of the tool. We can also look at evaluating the tool's development process. Has it been developed in a controlled way? We can move on then to sort of formal validation of the tool's behavior, where the tool is actually run through some standardized tests or other sort of testing regimes to prove that it is behaving as expected. We can also look at possibly finding if the tool has been developed against a suitable standard and to see if there is any evidence to support that. It's possible within some projects that you may want to look at using more than one qualification method. And that's possibly a good idea if you're working at higher integrity levels, where you may want to look at formal validation and also rely on any knowledge you have of using that tool in other projects, just to give you some extra confidence in its behavior. So looking again at these qualification methods, if we're looking at increased confidence from use, what we're really looking at there is saying that the tool's been used in the past and it's been shown to work correctly. It has to be used within a new project, within a similar use case, with a different, similar development environment, just to make sure that there are no differences in the use that might invalidate the confidence that we have in the tool. It is important, though, to understand that confidence from use can only be claimed as a sort of valid qualification of the tool when the same version of the tool is being used and the functional constraints are the same and that there is evidence to show that the tool behaved correctly in the past. And what that means is there has to be some documentation or some process artifacts to show that it has been used and has behaved correctly on a previous project. It's not going to be a particularly useful method if you're working with tools that change fairly often, in other words, ones where new versions come out on a regular basis, unless you are able to use a previous version on a new project. And we can also look at evaluating the tool's development process. That's usually related to sort of reviewing the development process that's been used by the tool vendor. And that may include a quality audit of the vendor, but it's more likely to be based on reviewing some artifacts or related documentation that have been produced by an independent assessment body such as TUV. And certainly within LDRA, we have TUV certification to show that our tools have been through an appropriate process for the tools to be used in safety-related projects. The important thing there is that however you go about this, what you're trying to do is establish that a robust development process has been used for the tool itself. So we're looking for something that's requirements-based, something that it has formal testing, there's issue tracking being used, and all of these things increase the confidence that the tool is likely to perform correctly when it is used within a project. Moving on to some more formal methods, we're looking at validation of the tool's behavior. So that's formal tool validation, and that is generally required when working at higher integrity levels. The validation itself can either be performed by the tool vendor, a third party, or even the end user of the tool. The independent or third party validation is generally preferred because it just gives a little bit of independence between a claim of the tool works correctly and proof that it does do what it claims. With compilers, it's fairly easy to find third parties that will either validate the compilers or even to find compilers that have already been validated. But that's not the case for quite a few other tools, in which case it really is helpful if you're working with a tool vendor who understands that tool qualification is needed. And if they have some processes or other support that can help you with that qualification, it can make that work a lot easier. You could also, in theory, look at trying to identify tools that have been developed to a suitable standard. Unfortunately, there aren't really any software or quality standards out there yet that are appropriate for the development of various software tools. So, for example, you're not going to find, or very unlikely to find, tools that have been developed to whichever flavor of 61508 is appropriate to the sector that you're working in. So what scope do we have to look at when we're looking at these tools? We have to think about, have all the aspects of the tool been qualified, or some limitations? For example, if you're using a compiler, it may be that only subsets of the language have been qualified. And obviously then you have to make sure that when you use the compiler, you are using it in a way that is compatible with the subset that has been qualified. Similarly, for static analysis tools, static analyzers quite often have many, many checks, but only a subset of them are needed. For example, if you're working with MISRA checking, you wouldn't necessarily need to validate all of the checks that the analysis tool is capable of doing, but you would want to validate those that are related to MISRA compliance. So this, I'm not going to go too much into the slide. This is really just showing that the various methods, there's different responsibilities. and evidence that's required to be gathered and pulled together to show that a tool can be considered as being qualified and that we're happy that it is going to work as expected within our environment. So which tools need to be qualified? Well, it's one of those things where it depends. Firstly, tools are going to need to be qualified if there is a domain standard that requires it. Most sectors have a requirement to satisfy IEC 61508 or one of its derivatives. And what that means is that tool qualification is required in a lot of cases. And so that would include, for example, control systems within the nuclear industry, within machinery development, within the rail industry, within automotive, and so on. However, qualification is also a good idea from protecting yourself from any liability claims whenever there is a risk that a failure of the software system is going to have a serious impact on product safety, security, or even just the reputation of the company. So really just stating what started earlier on, tool qualification really is just there to demonstrate that the tool is at least as trustworthy as the activity that it is replacing. Software development tools and verification tools need to be qualified. Development tools generate output that is actually part of the software, and therefore there is the chance that they could introduce errors into the software directly. Verification tools themselves cannot introduce errors, but there is a chance that they may fail to detect them. Typically, for example, if you're looking at a static analysis tool, you may be relying it to detect instances of undefined behavior, and it's possible that it may fail to point one out. So you do want to make sure that the tools are qualified. So looking at the development tools, any tool that can have an effect on the behavior of a product software needs to be qualified. So obviously we have the compiler, and that will include the linker and any other software tools that you use during the build process. And that includes tools like CMake used to generate build files or anything else that is directly related to the build process. Modeling and other tools used for code generation, so Simulink or MATLAB or any of these other tools, they would all need to be qualified. And in theory, you should also look at other tools related to the software itself, so the version control, Git, SVNs, IDEs, editors, all these other things that could introduce defects. When we're looking at the verification tools, we're there concerned with any tool that's related to showing that the behavior of the software is as expected. They will also need to be qualified. So that will include static analysis tools, dynamic analysis tools, unit test, and also possibly hardware in the loop or automatic test equipment where that is directly involved in running and capturing test results. When should they be qualified? Well, said earlier that they need to be qualified for each project, but you can use results from previous qualification activities provided that the use cases and constraints placed on the use of those tools are the same. And that's really where the tool evaluation is useful. If the evaluation shows that use cases are the same as before, it's likely that if you use tools regularly within various projects that you already have the evidence that you need. It is also possible that the evaluation process may indicate that the set of tools that you have to qualify for a project may be slightly different from a similar project. So the evaluation process is really very important. It shows what needs to be done, and it also helps to identify if it has already been done. So just looking at a couple of very brief examples, within 61508, Part 4 identifies various classes of tools. So it has these T levels. So T1 are tools which have no impact on executable code. That does say that text editors are not considered to be directly related and have no chance of introducing defects. I'm not entirely convinced. 61508 2010 is quite old. There are now a lot of editors, or more realistically IDEs, that can actually modify the code as you're developing it. So, for example, they can have quick fixes and automatically try and fix defects in the code. So there is a chance that they can edit the code in a way that is undesirable. The T2 level is for tools which only impact on verification activities. So that's going to be your static analysis and other testing tools. And T3 are tools which can actually introduce errors directly. So that will be the compilers and code generators. It then requires that an assessment is carried out for the tools in classes T2 and T3 to determine if they can be trusted. We need to be able to prove this. We need to identify potential failure mechanisms and how that may affect the delivered software. And if there are mechanisms identified, we have to put appropriate mitigation measures in place to make sure that tools don't introduce defects. I know it's not directly related to this session within ESSS, but one of the best cases to find more guidance on this at the moment is within the automotive ISO 26262 standard, where they have actually gone into quite a bit of detail about how the qualification of tools should be done. And in fact, within 26262, they introduced these concepts of tool confidence level, which itself is derived from something they call tool impact and tool error detection ratings. Tool impact is basically saying, is there a possibility that malfunction of a particular tool can introduce or fail to detect errors? If it is, then we need to go through the qualification process. Within 26262, a static analysis tool will be classified as a tool impact level of 2, which means that it would have to be qualified. The defect rating is basically an estimate of the likelihood of a tool detecting any errors or within itself or some other means. With categories there range from TD1, which means there's a high confidence that any tool is going to be tool error is going to be detected, to TD3, which means it's unlikely, so we have to worry about it. The tool confidence level is then derived from various lookup tables within the standard, and depending on what the risks are, we can then assign one of these confidence levels to a tool. And then from that, we can see which qualification methods are likely to be most appropriate to it. So, for example, for a static analysis tool, if it's assigned tool confidence level tool and the product is designated as ASLD, then the evidence of a tool certificate is going to be sufficient to establish confidence within that tool. If you're working at higher levels, for example, when you're working at ASLD and you're actually going to want some formal tool qualification, as I said earlier, it does help if you're working with a tool vendor that has something like the LDRA tool qualification pack available to help make it easier for you to actually verify that tool and prove that it is working as expected. So in quick summary, tool qualification helps to ensure that your product's safety, security, and functional requirements are satisfied. It will be required whenever there is a risk that a software defect could lead to a failure of a critical system. Any tool that is identified by tool qualification as being able to affect a product's executable code, either by injecting or failing to identify faults, needs to be qualified for use. Tool qualification must follow a documented process, and as part of that, you must produce a set of evidentiary artifacts to show that the process has been executed, and the documentation needs to record limitations in the scope of the qualification that results from that process. Tool qualification is much easier when you are working with suppliers who are willing and able to engage in the qualification process itself. It can be tricky to do, especially for some of the more complicated tools. So it really does help if you've got a good set of sort of vendor application engineers who can help you through that process. So if you need any more information or have any questions that you think about later on, please feel free to contact us at LDRA.